stuff on the front is kind of like your quiz 2.0. Can you close the Chromebook, please? Thank you. So you did this on your quiz. State a positive and negative coterminal angle for 7 pi over 6. So you're going to add a rotation and subtract a rotation. What is the whole way around in radians? Yeah, good. So 2 pi, which would be 12/6. So you're going to take 12/6 and add it. And then you're going to take 12/6 and subtract it. And just for the subtraction one, throw a negative in front of your answer to indicate that you went backwards. I didn't ask you to draw a picture of it here, but you certainly could if you wanted like a visual. This would be in the third quadrant. So what do we get if we add? 19/6. And again, I don't always say the pi, but there's a pi in there. And then this one you subtract, you get 5/6. But again, just put a negative in front to indicate you went backwards. That's kind of like you go that way, I'll go this way. We'll meet on the other side. This is the same thing except degrees. What is the whole way around in degrees? 360. Okay. So I'm going to take 360 plus a negative 95. I realize that looks like subtraction, but I'm actually adding a rotation because it's a negative 95. Like I'm doing 360 plus a negative 95. Anyway, however your brain goes through that, you're going to have to go ahead and subtract that. If you want to do the old school method, you're borrowing from the 6. Anyway, however you want to subtract. What is that going to be? 265? Am I doing that right in my head? Okay. Oh, did I do that wrong in my head? No, it's 265. Thank you. I like being right, especially when I'm doing the problem in front of a room full of people. It's always nice to be right. When you guys make a mistake, it's like your own personal thing. When I make a mistake, it's like in front of everyone. So it's embarrassing. All right. Now a negative coterminal angle. Come with me on this because it's a little tricky since this is negative. If you go backwards 95 and then you go backwards another 360, that will take you backwards enough. So what I'm going to do is 360 plus 95 and then just put a negative in front of my answer. So you want to go backwards 95 and then backwards another 360. So you kind of want to add those together, but then just make your answer negative. So if you add these, what is that, 455? Okay, cool. But backwards, yes.
A bit more like so I can understand it better. Can I write it the other way, like minus negative?
This is multiple choice, so write it however you want. As long as you can pick A, B, C, or D, you're good. A lot of the ones on the front of this paper are going to be multiple choice questions. All right, this is name that quadrant. If you want to write out your all students take calculus, you can do that. You can think directionally, like when you go to the right, X is positive. When you go to the left, X is negative, so on and so forth. A lot of ways you can think about this. I usually look at the negative one. I let that narrow it down for me. And then I use the positive one to pick between them. At the end of the day, guys, there's only 4 quadrants. You can give it a guess if you get stuck, okay? So sine being negative. Sine is positive in the second quadrant, and they're all positive in the first quadrant. So if sine is negative, that narrows it down to 2 or 3. Now, secant is positive. Secant goes with which one? Secant is the reciprocal of which one? Cosine. So secant is positive in, oh, I wrote the wrong thing. Sorry, I pointed to the correct ones and I wrote it wrong. I'm so sorry. I pointed to these 2 and then wrote 2 or 3. I'm so sorry, 3 or 4. And then secant is positive in quadrant 4. I'm so sorry. I pointed to the right. See, that's what happens when I make a mistake in front of everyone. Just saying that. So sine being negative narrows it down to 3 or 4. Because sine is positive in these 2, so it narrows it down to 3 or 4. Secant is positive where cosine is positive. Those are reciprocals. They go together, so it has to be quadrant 4. So let's try another one. I usually use the negative one to narrow it down. Cotangent is negative, so it can't be quadrant 1 because they're all positive there. And cotangent goes with tangent. So it also can't be 3. So that narrows it down to 2 or 4, and I wrote it correctly that time. And then I'm going to use the positive one to pick which one of those it is. If sine is positive, it has to be second quadrant, quadrant 2. Reference angles are either going to be 30, 45, or 60, or in radians, pi over 4, pi over 6, or pi over 3. So looking at this one, what do you think? 40. It ends with a 5. It's got to be 45. Radians are even easier. The denominator just matches. I think reference angle is the easiest question on there. That's an easy one. All right, cosine. First thing we have to do is figure out what quadrant we're in. Cosine is negative. So what does that narrow it down to? If cosine is negative, it can't be quadrant 1. Yeah, 2 or 3. So it can't be 1 or 4. So that narrows it down to 2 or 3. Tangent is positive, so that means it has to be 3. So we're going to draw a triangle in quadrant 3. Cosine is negative, so it has to be either 2 or 3. If tangent is positive in the third quadrant, so it has to be quadrant 3. You use the negative one to narrow it down to a 50-50, and then the positive one to pick which one of those two it is. So cosine is negative 5/13. Don't worry about the negative right now. We're going to place the 5 and the 13 first, and then we'll figure out which one is negative. Cosine is adjacent over hypotenuse. So it's going to go like that. This is your angle. So out of those two, which one gets the negative? Good. By definition, the hypotenuse cannot be negative. R is not ever negative. Now, I gave you another piece of information here. Tangent is 5 over 12, but this is one of those Locker combination ones. It goes 5, 12, 13, but, and this is really tricky, it's not actually 12, it's negative 12. Why is the 12 also negative? Quadrant 3. Okay, so just watch your negatives. All right, and then that's like your work. Then you use that to answer the question. We want sine. Sine is opposite over hypotenuse. So that will be what over what? Over 13. Good. Opposite over hypotenuse. Or y over r, if you want to think of it that way. There's a lot of ways you can think about it. This one's the same kind of thing. Little tricky, though, because it's not one of the Locker combination ones. We're going to get like a weird square root in here. And also, this just says negative 5. I want you to write it as negative 5 over 1. And I actually don't know which one's going to get the negative. I don't know if it's going to be the 5 or the 1. We're going to have to wait and see. Okay. Now, it comes right out and says quadrant 3. That's always kind of nice when it just tells you what quadrant. So triangle in quadrant 3. Now, I'll walk you through this. Cosecant is the reciprocal of which one? You guys are going to have to remember this. Try again. Sine. Good job. Sine is opposite over hypotenuse. So that means this is hypotenuse over opposite. Okay, you guys are going to have to remember which are the reciprocals of which ones, though. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so we just flip that. Are we all still together? Okay. I'm not going to do the negative. We'll decide that in a second. 5 is the hypotenuse. 1 is the opposite. So which one gets the negative? 1. Good. Now, this one was easier because it was one of those Locker combination ones. This one, we're going to have to do Pythagorean theorem to get that. Are you good if I call this side A? Is that okay with everyone? You can call it X. You can call it whatever you want. A squared plus negative 1 squared equals 5 squared. And you're just going to go through that and figure out what your other side is. Again, anytime you square a negative, it turns positive. So I got a squared equals 24. That is going to split. How would 24? Yeah, 6 and 4. So it's 2 square root of 6. But it's actually good. Why is it negative? In the third quadrant. Just be careful. I get that that's a lot. This is arguably, number 8 is arguably the hardest question on this entire piece of paper. I think so. You have to watch your negatives. You have to do Pythagorean theorem. Now you have to answer the question. Cotangent. Cotangent is the reciprocal of which one? Tangent. Good. Tangent, your TOA, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So that's going to be -2 square root of 6 over -1, which is actually just going to be 2 square root of 6. I think that's arguably the hardest question on this entire piece of paper. You have to like really watch your negatives. You have to do Pythagorean theorem. We had to split up the root. You had to, watch your adjacents and your opposites and all the negatives and things. So, I think that's the hardest question, in my opinion. Easy and difficult is always an opinion thing, though. All right, this is again like your quiz 2.0. We are converting these. So you're going to take your 340. Do you remember what you multiply by to change it to radians? Okay, perfect. Nice job, guys. Even with a weekend in there, you guys remembered it. The zeros cancel. It's 34 pi over 18, and then you just have to simplify the fraction. They'll both divide by 2. It's 17 pi over 9. Good job. To go from radians to degrees, you're going to do the same thing except backwards. So you're going to multiply by 180 over pi. You almost can't mess it up because if you get it the wrong way, the pi's won't cancel or the degrees won't cancel. Like if you write it wrong, you're hopefully going to be like, hey, wait a second. So you can do 5 times 180 if you want. I kind of recommend against that. I would leave the 5 alone and do 180 divided by 12. That's going to be, 15? Yeah, okay. And then 5 times 15, 75 degrees. What I wish the temperature was outside. All right, we'll do these two and then we'll do a break. Again, just like your quiz 2.0, all right? Arc length is just r times theta. Is the easiest formula ever. You just multiply the two things together. However, theta has to be in radians, and this one is not. So you're going to have to take your 40 degrees and do a conversion. It's not hard, but you have to do it. I gave you an easy number. So the zeros cancel. It's 4 pi over 18. And that'll reduce to what? 2 pi over 9. And literally all you're going to do is r times theta. So what was r? 6. Now, if you want to put the 6 over 1, again, multiplying fractions does mess some people up. You can always put the 1 there, multiply it by 2 pi over 9, and you just multiply the numerators, multiply the denominators. So that's going to be 12/9, which reduces, what do they both divide by? 3. 4 pi over 3, centimeters, feet, kilometers, yards, nanometers, meters. I made a problem in calculus. Like we do so much with feet per second, and I got tired of it. So I made it nanometers per decade just to like keep everybody on their toes because I got sick of feet per second all the time. Basically, the units is just checking you read the question, All right, and then your area of a sector is 1/2 r squared theta. I gave you this one in radians, so you don't even need to change it. We're just going to plug everything into the formula. So 1/2, what is our radius? 4. 4 squared is 16. Again, if you want to put that over 1, you can. Multiplying fractions does mess some people up, so if you put the 1 in there, that can help. And then times the 3 pi over 4. So you're going to multiply all the numerators, multiply all the denominators. Again, I don't want to lose anybody. Where did I get 16 from? 4 squared. Okay, I just want to make sure I didn't lose anybody there. All right, so 16 times 3, 48. So 48 pi over 2 times 1 times 4 is 8. Yeah, and then it is going to reduce, or you can cancel things. There's a lot of ways you can think your way through it. Those will both divide by 8. They'll both divide by 8. 48 divided by 8, 6 pi. Now this one is an area, so it will be, square yards or yards squared. So you can find like the area of how much pizza you eat. Although I hope your pizza isn't in yards because that would be a lot. So hey guys, for these next three, and we did this in the notes too, I want you to go ahead and we're just going to take a minute and write out your 6 trig functions for both of them. It's gonna be okay. Please close that computer. I had to say that twice on this recording now. It will help you remember which ones go together. Remember how before I said, cosecant is the reciprocal of which one, and you guys kind of stumbled on it? The more you write this, the better you will remember it. So you'll be okay. Everybody just take a minute and list them out. So we're going to draw our triangle. Let's decide what quadrant we're in. It says cosine is negative, so it cannot be quadrant 1. Here, where did I put my abbreviation here? I know I wrote it somewhere. Cannot be quadrant 1. And if cosine is negative, it also cannot be 4. Okay, so that narrows it down to 2 or 3. And cotangent is positive, so that means it is 3. Good job. Now, come with me on this. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. You don't have to write that if you've got it in your head. I'm just writing it so you can see it. So adjacent is 5, opposite is 2. However, perfect. They are both negative. Now you're going to have to do Pythagorean theorem to get the hypotenuse, all right? So it's going to be -2 squared plus -5 squared equals r squared. I'm calling it r because that's usually what we call it. You can call it whatever letter of the alphabet suits you. Again, when you square things, they turn positive. So these will both end up being positive. And I got square root of 29, which doesn't split, so you're going to just live with it. Which is actually great because it's less work. You just leave it alone. And now we're just going to list out all the answers. Okay. Now on here, I have you doing all 6. On the test, I might only ask you for a couple of them. I will tell you from experience, though, a lot of people do write out all 6 and then just give me like the 3 I asked for because it's easy to just match them up like this. So, sine is opposite over hypotenuse. So -2 over square root of 29. Cosecant, you're just going to flip it. I wait until the end to rationalize. There will be 2 that you have to rationalize, but just wait till the end. Cosine is adjacent over hypotenuse. And then secant, you're going to flip it. Tangent is opposite over adjacent. So that's -2 over -5. The negatives will cancel. Cotangent, you flip it. And this one was given to you in the problem. So you better not mess that one up because that was part of the given information. All right, which 2 do you have to rationalize? Yeah, sine and cosine. This will be -2 square root of 29 over 29, which arguably looks worse. And then -5 square root of 29 over 29. So this one gives you a coordinate point. What quadrant is the coordinate in? Good, 2. So draw your triangle in quadrant 2. Your x is -6, your y is 3. And we are literally just going to do the same thing over again. So if you were like, hey, I didn't quite get it, we're just about to practice it again. So go ahead and do your Pythagorean theorem. Let's all just make sure we get the same thing. Everybody just work that out on your own. We'll make sure we get the same thing. I got 45. Is that okay? Now that one does split. What will your square root of 45 split into? Yeah, 9 and 5. So 3 square root of 5. All right, and then you're just going to use this to answer the questions. We'll have to reduce and rationalize and all the things, but I just always write them out to start with. Sine is opposite over hypotenuse. So that'll be 3 over 3 square root of 5. Actually, I will go ahead and reduce that. The 3's are going to cancel. So it'll just be 1 over square root of 5. And so if you flip that, it's just square root of 5. Or you could write square root of 5 over 1. Nothing wrong with that. You can always put 1s in there.
Wait,
Okay.
like for the sign, when you cancel out the 3's, how is it not just square root of 5?
Because the square root of 5 is on the denominator,
Like if it was on the numerator.
then it would just be square root of 5. Cosine is adjacent over hypotenuse. So that's going to be negative 6 over 3 square root of 5. I'm going to go ahead and reduce that one. Negative 6 divided by 3 be negative 2. And then if you flip that, negative square root of 5 over 2. Tangent and cotangent will be a little bit easier because they're not going to have a square root in them. Tangent is opposite over adjacent. So 3 over negative 6, that'll be negative a half. Flip that, negative 2. Now, which 2 do we have to rationalize? Yeah, sine and cosine, and I kind of didn't leave enough space here. This one's going to be square root of 5 over 5. And this one is going to be, I don't have enough space, negative 2 square root of 5 over 5. I wrote it over here because I ran out of room. You obviously have a lot more room on the test. I try to conserve paper on test review and fit it onto one page if I can, just to save trees. All right, here, we're going to do the exact same thing we just did, but we have to come up with the point on our own. So you can plug whatever you want in for x, as long as it is what? Yeah, positive. See how this says x has to be bigger than 0? But you guys were real good at this. You want to be clever about what you plug in. What do you want to plug in for x? 3 would be a good choice because it's going to cancel out with the fraction. So if you plug in 3 for x, those will cancel. You'll get negative 2 minus y equals 0. You would add over the 2, so that's going to give you negative y equals 2. And so negative 2. Good job. That was hard with the negatives, though. That was a lot of negatives in there. We had to come up with the point on our own. You can plug whatever you want in for x as long as it's positive. We chose to plug in 3 because it'll cancel with the fraction. You can plug in whatever you want, but I don't want to deal with fractions. So I picked 3 so that it would cancel out. All right, what quadrant is that in? X is 3, y is negative 2. We're going to do Pythagorean theorem again. Hopefully you feel like we're doing the same thing over and over again, because we are. Which is honestly, when I really started to like math, I was like, oh, just do the same thing again. I can do that. Because then once you get the hang of it, you just keep repeating yourself. Square root of 13, and that doesn't split, so just leave it. I'm going to go ahead and just write these out. Can we just all make sure that they all match? Because at that point, that's just your SOHCAHTOA. It's the exact same thing that we did in the previous two. Again, sine and cosine are the two that you're going to rationalize. Bless you.
Is it always going to be this?
Not always. It turned out this way because I was trying to like give you some easier problems, so I made them all turn out the same. If you do go back and look at your notes from that day, I made some of them turn out different. So no, not always sine and cosine, just whichever two happen to have the root in the denominator. All right, I'm going to need you guys to listen well to me on this. I'm having this stay on the recording. Your work is a labeled triangle. And this is going to sound like I'm being mean, but I'm not, because I'm not asking for a whole lot. If you don't label the angle, I'm gonna take off. If you don't label the sides, I'm gonna take off. If you don't draw the axes and I can't tell what quadrant it's in, I'm gonna take off. I'm not asking for a whole lot, so you need to give me the bare minimum I'm asking for. Do you all understand? It's a labeled triangle in the correct quadrant, all right? So what quadrant is 300 in? Or draw a triangle in quadrant 4. What's your reference angle? Good. Why is it 60? Because that is correct. How do you get 60? Yeah, the whole way around is 360. Now remember, small, medium, large. 60 is the big angle. So across from it is the big side, which is good. Oh my gosh, you guys remembered it. It goes 1, 2, 3, small, medium, large. It is negative, thank you. And that means the other side is a half. That is the work I need to see. If you write anything less than that, expect to lose points. I'm not asking for a ton. Go ahead. You can if you want to, but it is always 1. By definition, for a unit circle, the hypotenuse is always 1. So you don't need to label that because it's just always 1. Yes, go ahead. Oh, okay. Let me know if you change your mind. Yes.
So this like thing with it's like the 65 or 6.
I had it up here, but it's gone now. See that? I could write it up again today, but I want you to get used to answering them without it. All right, now you answer the question. Sine is y because it's opposite over hypotenuse, but your hypotenuse is now 1. So negative square root of 3 over 2. So for this one, we went backwards 11 pi over 6. That's almost the whole way around. So what quadrant does that land you in? Yeah, good, because we went backwards almost the whole way. Radians are better in every way. Do you notice how I made the rest of these radians? That's because we got to let those degrees go. But they're better. Your angle for your triangle will either be pi over 6, pi over 4, or pi over 3, and it will literally just match. All right? A 1/6 is the little one. 1/6 is a little bit of pi. So across from that, you put the little side, which is a half. That means the other side, square root of 3 over 2. Nothing's negative. Why? Why is nothing negative? First quadrant. All right, then you answer the question. I wrote it behind me. Again, that'll be gone next time. Secant means you're going to flip the x value. This is your x value. If you flip that, it will look like this. And so your final answer, 2 square root of 3 over 3. Do you remember playing Quizlet? And then my team won. Yeah, you won every time. That was kind of awesome. All right, 7/4. What quadrant is that? And you almost went the whole way around. 4th, good. Your reference angle is pi over 4. Now, what does that mean? The sides are both what? Good. Now, one of them is negative, though. Is it the x or the y? Good. That is your work. If you write anything less than that, I'm going to take off points. And I know that sounds like I'm being hateful, but I'm not asking for a ton. That's it. Okay. Cotangent, it's behind me. It's x over y, but watch this. These are the same. The whole thing is going to cancel, and anything over itself is 1. It's just going to be -1. Thank you for not making me write square root of 2 over 2 over negative square root of 2 over 2, because it just looks horrible. It all cancels and you get 1. It's just negative. All right, what quadrant is negative pi over 4 in? 4th. Good job. You went backwards pi over 4. Oh my gosh, isn't that the exact same triangle that we just drew? That'll happen on your test too. You're going to get ones that are the exact same thing. Sine is the y value. So negative square root of 2 over 2. What quadrant is pi over 3 in? 1st. And your angle is just pi over 3. A third is a lot of pi. I do not recommend eating a third of pi. That's not a good idea. Across from that's going to be the big side, which is square root of 3 over 2. Stop talking over me. It means the other side's a half. Now look up there behind me. Tangent is what over what? Yeah, or it's still opposite over adjacent if you want to think of it that way. It's going to be square root of 3 over 2 over a half. 2's cancel. You get square root of 3 over 1, which is just square root of 3. If you left it over 1, though, full credit. I mean, it's the correct answer. Ooh, this one's a little different. It's a circle because it lands on the axes. So is pi over 2 up, down, left, or right? Good. So the point is 0, 1. That is the amount of work I need for one of those. Okay. Now it's behind me, cotangent x over y. Now, good. When do you get an undefined? Perfect. Can't divide by 0. Do you see another one that's like that? Can we try and find the other circle ones? Let's find pi. Yeah, 23. Let's do that. Let's do all those. Let's find those. Pi is to the left. So that coordinate is -1, 0. So that's I forget what I was even just going to say. My brain just left me. Never mind. I forget what I was going to say. Cosecant, you're going to flip the y value. Now that's where you can't flip 0. So undefined. Cool. And there's one more on there that is a circle. Yeah, 27. Let's do that one.
Wait.
Down is correct. So that is 0, -1. Tangent is y over x. So that's going to look like this. So again, that is undefined. You can't divide by 0. Cool. All right, let's go back and grab the rest of these. Those are all the circular ones. All right, what quadrant is 5/4 in? Third, good job. Your reference angle, pi over 4, it's just going to match both sides. Good. Negative square root of 2 over 2. That is your quote unquote work. And cosine is your x value, so negative square root of 2 over 2. Yeah, hold on. You can do the next one. Just make sure your answer's right.
How the reference symbol is higher than 4.
Correct. The denominators just match.
So whenever you see that, that always.
Or you could think of it as 5/4 minus 4/4 is 1/4. All right, you are correct. This one is in the third quadrant. I heard you say that back there. Your reference angle, pi over 6. A 6 is the little slice. So what goes across from that? 1/2. Good. Perfect. That means the other side. Perfect. And you're getting that now. I remember you had trouble with that last time. So nice job. They are both negative. So that is your work. Secant, again, I put it behind me. That'll be gone next time, though. You're going to flip the x value, which is this one. So it'll look like that. And so it is -2 square root of 3 over 3. Okay, 2 more. You guys have got this. Where is 2/3? Second, good job. You guys are on top of that. Like you really know your quadrants, which is very good. Reference angle is pi over 3. A third is a lot of pi. Do not eat a third of a pi. That's not a good idea. So across from that goes the big side, square root of 3 over 2. Other side, 1/2, but it is negative. Good. Cosecant, it's behind me. You're going to flip the y value. I skipped the middle step on that one because we did it twice already. So I hope that was okay with everybody. All right, last one. Where is 5/6? Second, good job. Your reference angle is a 6. That's a little slice. Across from that, 1/2. Other side, square root of 3 over 2, but it's negative. Are you instigating over here? It's the x value, which is negative square root of 3 over 2.